Imagine a material so strong and lightweight that it's revolutionized industries ranging from aerospace to sports equipment. Today, we're diving into the fascinating world of carbon fiber. Welcome back, fellow enthusiasts, to another episode of How It's Made. Today we have an extraordinary material on our hands, carbon fiber. It's not just your everyday fabric, it's a game changer that has taken the world by storm. So, buckle up and get ready for an exciting journey into the production process and mind-boggling applications of carbon fiber. Carbon fiber has become the go-to material for countless industries, and there's a good reason why. Just think about it, a material that's stronger than steel, yet lighter than aluminum. It's like a superhero among materials. But before we delve into the nitty-gritty of how it's made, let's get a solid understanding of what carbon fiber actually is. At its core, carbon fiber is a composite material made up of thin, incredibly strong carbon fibers that are bonded together by a polymer matrix. It's this unique combination that gives carbon fiber its exceptional properties. The secret lies in the carbon atoms themselves. They arrange themselves in a crystal-like structure, forming long, interwoven fibers that create an incredibly strong framework. And the best part, these fibers are super lightweight. It's like having the strength of a heavyweight boxer in the body of a nimble gymnast. Now that we've got the basics down, it's time to dive into the production process of carbon fiber. Trust me, it's a fascinating journey from start to finish.
Hey everyone. Welcome back to DSP Factory Made. If you enjoy what you're about to see, don't forget to hit the like button, subscribe, and ring that bell for notifications. Let's dive in.
Now that we have a grasp on what carbon fiber is, let's delve deeper into its fascinating properties and intricacies. Carbon fiber's exceptional properties have made it a true game changer in various fields. Its high strength-to-weight ratio means it can handle enormous loads while remaining incredibly lightweight. This property has caught the attention of industries like aerospace, automotive, sports, and even the medical field. But what makes carbon fiber so strong and lightweight? It's all in the manufacturing process and the arrangement of those tiny carbon atoms. The carbon fibers are meticulously woven together, creating a strong and rigid structure. These fibers are then bound together with a polymer matrix, forming a composite material. This composite structure is what gives carbon fiber its exceptional properties. Not only is it incredibly strong, but it also boasts excellent rigidity, meaning it resists bending or deforming under stress. This rigidity is vital in applications where maintaining shape and stability is crucial. Another fantastic characteristic of carbon fiber is its resistance to corrosion. Unlike metals, carbon fiber doesn't rust or degrade when exposed to moisture or chemicals. This makes it ideal for applications in harsh environments such as aerospace or marine industries. Additionally, carbon fiber exhibits low thermal expansion, meaning it doesn't expand or contract significantly with changes in temperature. This property makes it an excellent choice for applications where stability under varying temperatures is essential. Now that we've covered the properties of carbon fiber, let's explore the different types of weaves commonly used. The two most prevalent weaves are plain weave and twill weave. Plain weave features a simple crisscross pattern, while twill weave has a distinctive diagonal pattern. Each weave offers different aesthetic and performance characteristics. Understanding these properties and weave patterns is crucial for maximizing the potential of carbon fiber in various applications. Now that we have a solid understanding of carbon fiber and its properties, let's take a behind-the-scenes look at how this extraordinary material is made. The production process of carbon fiber is a meticulous and intricate one, involving several key steps. So let's dive right in and uncover the secrets behind creating this remarkable material. It all begins with a precursor material called polyacrylonitrile, or PAN for short. The PAN fibers are spun and formed into bundles, which will later become the carbon fibers we know and love. This polymerization process is essential to create the base material for carbon fiber production. Once the PAN fibers are formed, they undergo a process called stabilization. This involves heating the fibers at high temperatures in the absence of oxygen. Stabilization removes non-carbon atoms from the PAN fibers and aligns the carbon atoms, creating a stable molecular structure. After stabilization, the fibers go through carbonization, a process that takes them to even higher temperatures. This intense heat treatment removes any remaining impurities and converts the stabilized fibers into pure carbon fibers. The carbon content increases significantly during this stage, further enhancing the strength and durability of the fibers. To optimize the bonding properties of carbon fiber, a surface treatment is applied. This involves adding a coating or sizing to the fibers, which helps improve their adhesion with other materials in the final composite product. The surface treatment ensures strong and reliable bonding between the carbon fibers and the polymer matrix. And there you have it. The 4 crucial steps of carbon fiber production. But don't be fooled by the simplicity of these descriptions. The actual process involves precise control of temperature, pressure, and other variables to achieve the desired properties of the carbon fibers. Now that we've uncovered the secrets behind carbon fiber production, it's time to explore the incredible range of applications where this remarkable material shines. In the next section, we'll discover the industries that have been revolutionized by carbon fiber. Now that we've witnessed the fascinating process of carbon fiber production, let's explore the diverse range of industries and products that have been revolutionized by this incredible material. Carbon fiber's exceptional properties, such as its strength, lightweight nature, and rigidity, have made it a sought-after material across various sectors. Let's dive into some of the most notable applications of carbon fiber and see how it's shaping the future. Carbon fiber has truly taken flight in the aerospace and aviation industry. It's extensively used in the construction of aircraft, rockets, and satellites. Its lightweight nature allows for fuel efficiency and increased payload capacity, while its strength ensures structural integrity and safety. In the automotive world, carbon fiber is driving innovation. High-performance vehicles utilize carbon fiber components to reduce weight and improve aerodynamics, resulting in enhanced speed, handling, and fuel efficiency. Carbon fiber is also making its way into electric vehicles, where weight reduction is critical for maximizing battery range. Carbon fiber is no stranger to the sports arena. From bicycles and tennis rackets to golf clubs and snowboards, carbon fiber is revolutionizing sports equipment. Its lightweight and high-strength properties give athletes a competitive edge, allowing for faster speeds, better control, and improved performance. Even in the world of construction and infrastructure, carbon fiber is making its mark. It's being used in the construction of bridges, buildings, and even reinforcing existing structures. Carbon fiber reinforcement provides added strength, durability, and seismic resistance, transforming the way we build and maintain our infrastructure. The medical field is also benefiting from carbon fiber's exceptional properties. It's used in prosthetics, implants, and medical devices, providing lightweight and durable solutions for patients. Carbon fiber's biocompatibility and corrosion resistance make it an ideal choice for medical applications, improving the quality of life for many individuals. These are just a few examples of how carbon fiber is shaping the future across various industries. Its versatility and exceptional properties continue to inspire innovation and open new possibilities. As technology advances and manufacturing processes become more efficient, we can expect even more exciting developments in the world of carbon fiber. From space exploration to renewable energy, the possibilities are truly endless. And remember, if you have any thoughts or experiences related to carbon fiber, we'd love to hear from you in the comments below. Thank you for joining us on this captivating journey through the world of carbon fiber. Stay curious, stay inspired, and we'll see you next time on How It's Made.